one of the laws that we're going to study in this chapter is something called the conservation of energy. It's very similar to the conservation of momentum. Energy cannot be created or destroyed. Okay, but well, what is this realistic though? Is there any spring anywhere that would look like this that would just continue to go on forever and ever? Why not?
Because energy is lost in heat, right?
Yeah, energy is lost. Where, I mean, is it destroyed?
No.
No. What is it turned into?
Thermal.
Yeah, thermal energy is turned into heat, okay? In the form of, and the way that the means that happens is friction. You're like, where's the friction? This isn't sliding across the ground. It's not like rolling. What's that? I did put none friction, but where's the friction though? I don't see it sliding across the floor.
In the spring.
Yeah, it's actually in the friction between the particles that make up the spring. They're like stretching out and they're like getting jammed together and they're like going, you know, and as they run into each other, then they are losing some energy, okay? So if I turn the friction on here, you'll notice this part right here, the thermal, is going to start becoming a factor here. All right. In fact, thermal is rising. This thing's getting hotter. Well, it's probably momentarily getting slightly hotter in some areas and then cooling off. And so then that heat, then the spring is heating up, but then it sort of heats up the air around it, and so then that air heats up like the walls in the room, just like the smallest amount, like a fraction of a degree. Okay, and then, you know, now this is in 1/4 time. Let's put this in real time so it'll be kind of going back and forth. Notice we still have some elastic potential energy here because I pulled it down. We still have some kinetic energy, but wow, that thermal, it's not as totally eaten up what would have otherwise been the kinetic energy. Does that make sense? So that's why we say we have lost the energy to thermal, because you really can't recover it. We can't take that thermal energy and then make it start moving around again. Okay? All right, I think that's pretty good. Notice if I push it, if I put it right here, you can see total energy. What happens if I compress the spring even more? What's going on with that total energy? Yeah, it's increasing because I've got more potential from the elastic. Yep. And then if I put this one on over here and I show energy 1, whoa, why is that energy like total? Because of the mass. You get that? This is 2 total energy because it's higher mass. Here's 1 total energy. Mass is smaller. Okay. Let's talk about pendulums now.